So this slide explains the interaction of the chlorine free radical with ozone, which is O3, and it's a series of steps which is complex beyond the realm of this course. What I want you to notice, and I've mentioned it in the other video, is we start off with it, and at the end we end up with O2, which is the decomposition product of ozone, and the chlorine free radical is back. If you added up all these guys and you pretended this like it was an equal sign, the arrow, it would add up to this very simple equation, which is the decomp of O3 to O2, and that's bad. Now, what I would like you to get out of this is the catalyst. What is a catalyst? A catalyst is a chemical substance that participates in a reaction, influences its speed, speeds up the reaction without undergoing permanent change. And what it is a very important concept in chemistry, a very important tool in chemistry. Catalysts are used almost everywhere in industrial chemical reactions. What is nice is that you have a species that you introduce at the beginning and then is probably consumed during the reaction, but at the end it's reproduced again. So a little dab will do ya, and it is a very, very efficient method for controlling a chemical reaction. So please know the definition of a catalyst. Chlorine in this case, she's consumed in the first step, then reproduced at the end of the second step. And so what happens is one chlorine, notice that little dot there, that means she's got an unpaired electron, makes her very, very reactive. She can catalyze the destruction of as many as 10 to the 5th ozone molecules, or 100,000 molecules. Now, we're going to talk later about the global response to climate change with the increase, trying to control the increase of man-made greenhouse gases. But let's look now at the response to the ozone thinning. So this one was pretty decisive and swift, 10 years, 20 years, but the steps have been taken to limit the manufacture and use of CFCs, chlorofluorocarbons, commonly called freons, since 1978. They were banned in spray cans, so they were not released to the air, but they stayed in closed systems like air conditioning and refrigerators. And then in 1987, the global response came from the Montreal Protocol, and many nations agreed to greatly reduce production. It took a little while because the substitutes were not readily available, but they did come. And more stringent limits were set in 1992, and there was a complete ban of CFCs by 96. So within the first discussion of, or the first notice of the thinning to them being banned, about 2 decades. And that's pretty fast when you have this world you have to respond to. What happened is, what's supposed to happen is the scientists provide the data, industry responds by hopefully coming up with alternatives. And I think that's the big difference. There is no alternative to the burning of fossil fuels. 85% of our energy comes from burning oil, natural gas, and coal. And you can't turn that off. Not even in 20 years like this worked out. But the first ozone depletion reported in 74. The Montreal Protocol signed in 78. And this is how many tons of CFCs were produced. And look at it drop. Boing! And then here we look at the free radical, the chlorine coming down. And thank goodness it happened, because I think I mentioned before that the maximum thinning of the ozone layer around the Antarctic occurred in 2006. So if this had not been done, you kind of wonder what catastrophe would have befallen. The UV radiation coming on Earth would sterilize biological systems. Now, air conditioning was not going to just be in one part of the world. It is a It's not just a status symbol. It is a important part of a lifestyle. They're growing at 20% a year in China and India. Scientists are alarmed by the impact on which the gases in which they run. They're all potential global warming greenhouse gases. The CFC 22, this has got a hydrogen substituting for one of the halogen atoms. The newer, they pose little damage to the ozone layer, but like I say, the concern is their performance as greenhouse gases. And these are all, this is City Street in India, and you can see all the air conditioning units. I would be hard pressed to give up air conditioning. Oh my goodness. I remember as a child not having it and spending much time in the basement because that was the only cool place to go.